So now let us try to understand how can we visit all the items stored inside a linked list. Sometimes this problem is called list traversal problem. That is, traverse the entire list starting from the beginning to the end, and in this path you have to visit all the nodes. So how can we do that? Now, from the previous video we have learned that the first node of the linked list can be identified using this head. We have also learned that the last element or the last vertex of the linked list always point to something called null. So now the problem is, the list traversal problem is, we have to visit all the nodes in between head and null. And also you have learned that we can access each node starting from the head by utilizing the next link. So here you can see the easy pseudo code to traverse the entire list, that is starting from head ending at null, utilizing these next links. So what I have done in this pseudocode, first I have created a temporary vertex called VTX and initialized it to head, that is in the first node in here. Next I have started a loop where actually I have checked the condition, that is until the next link point to null. That means whenever it will hit null, the loop will break, and until it is not hitting null, it will keep on going and keep on iterating. So, and inside the loop what I have done, I have written like just visit the vertex. So visit the vertex means you can think of like print the element inside the vertex, like let's say print then VTX dot data item. So something like that you can think of. So after visiting, what I have done is, after in the end of each iteration of the while loop, I have used VTX equals VTX dot next. That means I am moving the temporary VTX pointer to one vertex or one element ahead. So first it started from head. In the end of the first iteration, it will point in here. So it will print the data item, that is Z, in here, and then it will point to this node. In the end of the next iteration, VTX will point to this node. In the end of next iteration, it will point to this node and print or visit this vertex, and finally whenever it will come to this null, it will break the entire loop. So basically this initializing to head is the initialization of my while loop. VTX dot next not equal to null, that is the condition for the while loop, and here it is visiting the nodes, and VTX equals VTX dot next, this last line is the how I am modifying that temporary pointer. So now the question is, can you traverse the list in the backward direction? Well, the short answer is no, you cannot. So let me just remove this print line so that you can easily see. So the short answer is you cannot traverse the list in the backward direction. Why? Because all the links in this list point to the next vertex or the next node or the next element. The arrowheads are all in this direction. So in order to access the previous node, you may need to use another data structure called doubly linked list, where we can introduce another extra link which points to the previous vertex of the linked list. And by utilizing that one, we can easily traverse the linked list in the backward direction, in the reverse order. But that we are going to understand later.